Hello and welcome back. Okay, I've not got either the sound or the UART attached at the moment, so this is just the core CPU components plus my little LCD module. Okay, so what I'd like to look at today is moving towards getting the remaining components of the core processor converted to PCB. That's the ALU and the clock. Now, trying to work out how big those need to be is not the easiest thing in the world, but I can kind of roughly estimate it by kind of counting the number of chips on here and looking at the kind of similar amount of real estate it takes over here. So I actually think I can fit the ALU and the clock into the space below the pipeline here. So the central processing unit will occupy that space, giving me this space for peripherals. So what I want to do is start planning out exactly the size and shape of some of these boards and use that information to create a new backplane, which I'm going to replace the area behind the pipeline and create a new section here to start designing and building those individual modules. Now, one thing to note is the ALU is starting to get quite fragile. These are very cheap breadboards and this wiring's quite old, and so sometimes it takes me a little while to find out what wires come loose to get it working again. So at the moment I've got the Fibonacci code loaded onto this ROM, so I can test any changes I'm making, because if it comes out with the value 23 equals 46368, I know that things are in a reasonable state. I've got the clock here set to about as fast as I can support with the LCD display. I want to improve that at some point. Okay, so let's get to designing this layout. Right, so here's my backplane design as it currently stands. Now, I haven't shown you the video for this, but this region down here is my planned space for the clock module. And I would really like to fit the ALU into this much space. That will give a nice rectangular profile for the core of the CPU. Though to be specific, I think what I'd like to do is move the pipeline down from where it currently is. I'm confident there's enough space here to fit the ALU, but I want to break the ALU into 4 modules, and so I need to work out a kind of a jigsaw puzzle in reverse. So we've got the shift unit, the bitwise logic unit, we've got the diode matrix that handles control decoding, and then we've got the kind of adder and flag handling. Obviously on the final backplane, this will probably go right next to the register stack. Right, so the left-hand input for shift, it's got 5 chips for the shifting. I think it's going to be easier if we put the output latches onto this board. And right-hand side just has 8 chips for the logical function, plus we want the output LEDs and the output latches. So this area here has slightly more chips than one of these GPRs, and this has slightly more chips than one of these. That looks about right, to be honest. Right, so what I need to do now is create stub projects for these 4 modules. Okay, now that flags, we're going to want that on ALU output phase. The right hand side actually has both left and right as inputs. Whereas left hand side only has the left. It's because right hand side does the logical operations. And that forms one of the inputs to the output stage. Now, doing this as like a reverse jigsaw puzzle is kind of difficult. The main thing is I need to estimate the ratio between these sections. This feels about right. Maybe this bit's a bit big, but I do want to be able to write next to the LEDs the functions, because that will just make it a lot clearer. Right, so that's the primary input and the output. But we also have two control lines that select the shift that's happening. We're going to need power and ground, and if we put the latch on this board, we want the clock for the latch as well. Now, ALU clock is a modified clock line which only happens when an ALU operation is in progress. That gets used for driving the internal latches. All the modules need that. ALU control is where they're going to get generated from. So these are directly outputs from the diode matrix. And the top two are the carry selection. We don't need all of those there. Left hand side just needs these two. Actually, I think I'll use a 4-pin header for this. And of course, this output phase also needs the main bus. That would have been too easy to forget. Right, I think that's actually everything that the ALU output needs. That's everything LHS needs. It's only control we're worried about now. It's the outputs. These are actually also outputs apart from power and ground input. But we need the main system clock and the 4 ALU operation selection lines, which is exactly what we got here. So here's the main input to ALU control. So it's the 4 lines that control operation selection and the system clock. We don't need reset here. That outputs these 8 control lines and derives the active and the clock line. Now we need to rough out the PCB layouts so we can make these inputs work. Now what I want to be able to do is bring this into the PCB, and if I tell that to update, let's do the same to RHS. If I put them up there like that, I can make them line up with the output LEDs. Right, I think that's about ready to go across as well now. Right, just one bit left. I'm trying to name these such that there's no clashes. This is interesting. Kind of actually want to control this from the backplane location. Right, so I'm going to do the same as I did temporarily for the pipeline. And I'm going to make this as just this slice and then cross connect the bits that are necessary. And only when I'm done with the whole thing will I make one big uber backplane. Now when I made the main backplane, I did stick a couple of capacitors next to every power rail for the daughter boards, and I haven't done that so far on this bit. I've not experienced any problems with the pipeline, but I don't want to tempt fate, so I'm going to go ahead and add those. Okay, that's as far as I want to go with the main backplane. Obviously we're never going to make this because we've cut out a lot of these cross connects internally before we do. Now we're definitely going to want to cross connect these, and we've got that little mini board that can do that already, but I also think now we need to cross connect the main bus. Right, so the edge was on a grid line, and then there were two spots before the pins. Maybe we should give it a whole 2.54mm gap, because that's what we've done between all the other PCBs. And since we've definitely got the main bus over here, I'm going to stick a few extra instances of the main bus. Right, well we don't actually want any of those. Okay, as per usual, I'm going to add some copper fills. I'm kind of bracing myself for this to be a pretty expensive PCB again. Now, the first time I connected the previous version of this board up, just as a little interconnect, I put it on the wrong way around. So I'm quite relieved to see that there is no way to get this one wrong. I'm quite looking forward to this. All in good time for these. Right, so this one is quite similar to the original one I made for cross-connecting the main register and memory backplane with just the pipeline backplane. But I dropped the extra connections in the middle because I'm just not using them. And I added the bridging for the main bus. This will be quite handy because I added main bus terminals all the way down the right. And as you can see with the way I'm currently laying out well, I should call it a computer now. I've got quite long ribbon cables daisy chained off to connect main bus up. So I've also got this one to cross-connect ALU functionality. Right, I need to get set up for soldering. Okay, first thing I always do is give a PCB a good clean with a bit of IPA. I have noticed the soldering get a lot easier since I started doing that. I think I'm going to do these interconnect boards first. Now I did put both copies of the main bus transfer on here, but I actually only need one on each side. I suppose I could do both to guarantee a low resistance connection. This trick for holding all the pins in the right place is so obvious once you know it. Looks like I can't count. Put this one in the wrong way up. Right, it's first interconnect done. Now I did break out the ALU drive lines. My plan was to put a female connector on there, but I'll leave that for later. Now I need to go and find some pin headers to do these. Okay, well I've dropped my soldering iron temperature down to 320 for this. I don't honestly know how much good these caps are doing, but I have been adding them to the backplane boards to try and reduce any noise that's coming across. This one does look a little bit messy to me on that left-hand side. I don't trust it. I'm going to replace it. These little surface mount caps are not designed for mechanical stress. I'm not having fun with this one. Okay, now everything that connects to a daughter board is one of these turned pin headers, but then all the perimeter connectors are going to be regular female DuPont style. I'm pretty sure there's going to be some point in this process where all of these fall out, so try not to laugh too loudly. Now I think if I put another one of these underneath, I should better get them to sit flat. And my biggest fear is I've missed connections that are necessary for these boards. Okay, it's everything apart from these. And these are all connected to ground down here. And I've only really put them in because this is where the control buttons are going to be for the clock. And I wanted a little bit of extra mechanical support. Now I need to find the right way of flipping this over. Okay, they feel like they're all in the right place. So my hope is sandwiching this PCB on like this will keep them all in the right place. Bringing the solder temp back up to 360. Now I know there's one down here that's going to fall out because I haven't soldered it, because I put the pins in the wrong place. But hopefully the rest are going to be okay. This one I think is leaning over, so I might need to fix that up. That looks pretty good. That one's got a bit of a twist on it, and that's leaning. These things actually get hot. Okay, at first glance, that looks pretty good. Now we've got all these connectors around the edge to do. Now these are going to be handy for some of them. Just need to find something to prop this side up to keep it level. Looks about right to me. Most of the challenge now is trying to work out the right way to support these bits while we actually solder them. See, that was foolish. Not quite aligned correctly with those ones for support. All these extra main bus connections down the side here. I don't know if I'll ever use them all. But up till now I've always been daisy chaining the main bus connections between breadboards, which is just asking for trouble. I've got 6 of them all in a row. No easy place to connect this one. Let's see if I can just hold it. Appears not. I think everything is there and soldered. That is awesome. Okay, now this is going to be a bit of surgery. Switch it off for that. This is the clock. It's only got a very limited number of connections. This is the brake line. It's reset, and that's clock. Now these were just cross-connecting grounds. Right, here's the flags. These should directly line up with these two. It's mem data. That one's going to be a source of annoyance in the future. Left and right hand side operand. Now this little daughter board is designed to connect LHS and RHS between the two backplanes, but I don't know if I should use that straight away. That's a main bus connection. We should be able to use a much shorter cable for that because we've got the main buses down the side. For starters, that's a large amount of the connections made in one hit. Now, while things are temporary, before we've got the ALU here, some of the positioning is actually less convenient on this board. Alright, so this is the other way around, so it's a clock at the top. Now, if I do need extra tying of ground, that would be a convenient place to take that from. Right, and that top line is reset, might be handy. I did work out a while ago that I could connect a DuPont style connector to a turn pin with the cunning use of one of these headers. That's kind of convenient because, say I replace this PCB next, then I can disconnect that from there, move that to the output and move that up. It would be quite nice to be able to do that incrementally. So all we're really missing now is the clock. Should be able to find a much shorter cable for this. Now this is cool. We can give things their own main bus connection. It's going to make it a lot easier to move stuff around to work on it. All of that I'm hoping to get into that space. But right now there's nowhere obvious to put it. Right, gonna have to make that a priority. Might be able to daisy chain the clock out of there, but that is asking for trouble. Where am I going to get break from? That should be down here somewhere. No, it's actually there. I don't have any DuPont wires long enough to make this. May have to make one, but I do want to get this board done quite quickly, so may not be a big deal. Okay, well, I think I've accounted for everything there. There's a lot of these wires, so that was mem data I hadn't connected. A lot of these wires can be a lot shorter now. Let's give it some power and see what happens. Right, CPU is in break state with a break instruction at the top and 2 NOPs, which is exactly what it would normally be in after this code completes, and it seemed to take about the right length of time. But obviously this is not correct. So reset, recognize that as a load, but that seems to be working right. Okay, I'm seeing a lot of the right text appear on there. It's working. That's an error though. Okay, I don't know if it's the entirety of it, but this is definitely a problem. Least significant bit is the opposite side to how I've wired it. Value 23 equals 46368. So that is working. Okay, I'm actually quite relieved. Now this feels very precarious at the moment, but the rest of this feels much better. I think actually I'll do the clock PCB next. Get rid of this half-balanced board, and then we've got everything flat against the backboard, and we can start working on the ALU PCBs. That'll be cool. Okay, well I suspect this video is going to be quite a long one because there's quite a lot of PCB design and soldering, and so I'm going to call it a day there. But I'm really pleased with this because I've opened the door to a lot of rapid development of the PCB side of the processor. So hope you found this interesting. Thanks a lot for watching, and I will see you again soon. Goodbye.